Welcome to the homework instructions video for assignment 3.06, number 3. So this time we're graphing the cosines, which are a little more finicky and more difficult to work with on IXL than the sine function. So f equals cosine of x. We can just drop in the cosine and we're done. For that negative cosine of x, we just bring that down to the negative 1. Here we have a negative 4. So our amplitude comes down to negative 4, and then we add 1. So we shift that up from here. Now we have a 2 cos x minus 2. So we have a 2 with the cosine of x, and then we bring it down to 2 cos x plus 1. Again, we change the amplitude first. Then we bring it up 1. And now we have a 2 cosine the negative x, but the negative of x doesn't actually change anything because the cosine is symmetrical about 0. So we can ignore the negative x. If we had a phase shift to go along with it, we would have to do more, but we don't, so we can just ignore that and drop it down 2. Similarly, the 3, that negative x can be ignored because we have no phase shift, and then bring it down 1. And now this one, f of x equals the cosine of x over 2. 2 pi divided by 1/2 is 4 pi. So we need to turn this into a function with a period of 4 pi, not 2 pi. So we're going to take the distance we have between pi over 2 point and our max and double it. So that'll change our 2 pi period into a 4 pi period. But notice that seems to have shifted our peak to the left, and we didn't want that. There's no phase shift. So we have to then drag this back to the right. It's one of the issues I have with the IXL interface for graphing these. Here we bring that up to 4. And then this 2x, 2 pi over 2, is just pi. So our period has to be pi. So we need to shrink this to half the distance it was. And then again, there's no phase shift, so we need to move that max back to the y-axis manually. So amplitude first, our 1 becomes a negative 2. Then our period. We have that 2x. This has to become half that distance to make it a period of pi. We shift it back to keep the minimum there, and now we drop it by 2. So here, no amplitude. We'll deal with the period first then. So x over 2 means this is a period of 4 pi. So we have to double that distance and slide our maximum back to the y-axis, and then add 1. Now here we have a negative 5 cos x plus 1. So there's our negative 5 times the cosine of x, and then we add 1 over here. 5 cosine x minus, or x over 2. So there's our amplitude of 5. And that x over 2 means our period is now 4 pi, not 2 pi. 2 pi divided by 2, or sorry, 2 pi divided by 1/2 is 4 pi. So we bring that out. Then we have to shift it back. So now this gap 2 pi is only half of our function. Our minimums go from -2 to +2. That is a 4 pi period. Now here, cosine of 3x. Simple enough at this point. Our amplitude is negative 4. Our period is going to be pi, or 2 pi divided by 1/2, which makes 4 pi. So we double our distance and shift it over again. So that is now 4 pi between the two maximum. We're good there. And then we have to add 2. Now we have cosine of x minus 2. That one's fairly straightforward. we have a negative 1/2 cosine x minus 1. Now here we have a 2 and our phase shift x minus pi is a phase shift of pi units right. So we end up here. Oh, but I almost forgot that amplitude change of 2. So now no amplitude change. We do have a period change and a phase shift. So the period has to be pi over 4. We'll slide that back to the origin. So that deals with the 1/2 here. Then we factor that 1/2 out. That leaves us with an x plus pi. That's the same as a phase shift of pi units left. So this x-intercept we have at pi now happens at 0. So now for the challenge zone. That's an amplitude of 3, and the x minus pi makes for a shift of pi units right. So this peak that we have here at 0 has to end up over the pi. So we slide until that peak is over the pi. And again, we have an amplitude of 3 and a phase shift of pi over 4 units right. On this scale, that's going to be 1.5 boxes. So that's here. Now an amplitude of 3 and a phase shift of 3 pi units right, which is the same as a phase shift of pi units right because we have a period of 2 pi. That's the only way we're going to get this whole thing to fit on the graph. So now we are going to have an amplitude of 3. Our period is now just pi. So we have to cut that distance in half and then slide it left again. And when we factor that 2 out, we have an x minus pi over 2. That is a phase shift of pi over 2 units right. So this peak that we have here is going to have to end up at x equals pi over 2 when we're done our phase shift. We have an amplitude of negative 3, so we drag this 1 down to a negative 3. This 2 means our period is pi. So to cut that distance in half, and then move it back because we weren't trying to shift that. And when we factor out a 2, we have a phase shift of 3 pi units right. But 3 pi is a multiple of the period. Our period is pi. So shifting at 3 full periods will make no difference in the function, and we can submit. All right, now we are hopefully nearing the end. I believe we have 4 questions left, but we've got all of our parameters in play. So first, amplitude of negative 5. That one goes to a negative 5. Second, this is equivalent to having a negative 1/2 times x plus 3 pi. So that negative 1/2 makes our period 4 pi. So you're going to go to that 4 pi here and shift it back. So now peak to peak is 4 pi units apart. When we factor out that negative 1/2, that negative is doing a symmetrical point about this, but whatever, we've got that symmetry. So this is going to be 3 pi units left. So this point has to be there. And now we bring it down 1. So it's a little complicated. So let's demonstrate how all these pieces fit together. So we have a negative 5 cosine negative x over 2, and then minus 3 pi over 2. Minus 1. So we could see the same sort of graph here at a peak, with a peak at pi, specifically pi and 4, and then our, I really didn't want to do that. Right, peak at pi 4, and then we have a pi minus 6 minimum. Okay. So that is how all these pieces fit together. It can be a little convoluted getting there, but we got there. So now a -3 times the cos, we bring that to a -3. That 2 means our period is just pi and not pi over 2. We have to squeeze that halfway there. If we were to factor out the 2, we'd have a plus 3 pi. So that's a phase shift of 3 pi units left. But again, that's with a period of pi. So moving multiples of pi makes no difference in the final graph. And we can bring it down 1. Now here we have an amplitude of -2. That 2x here means we have a period of pi, so you have to bring that half the way and slide it over. If we factor out that 2, we have an x minus pi. So that is a phase shift of pi units right, which is exactly our period. So it makes no difference. And the last piece we need is that -3. So we bring it 3 units down. All right, now if all goes as planned, this will be our last one. Amplitude of 1/2. That -4 means that our period now has to be pi over 2. So we need to keep squeezing that in here until what happens at pi over 2 is the same thing that happens at 0. And we need to shift that so our peak is back at the top. If we factor out a -4, we'd have an x minus 2 pi. So that is a phase shift of 2 pi units right, which lands us at exactly the same point on the curve. It's a peak at both areas, or both locations. And then finally, we add 2. And there we go.